In the previous video, we discussed how we can insert a new element into the array structure and how we can delete existing elements from the array structure. And we make use of a list type in Python to represent an array. This time, we're going to discuss the advantages and disadvantages of the array structure. We know for a fact that an array is a structure of elements which are contiguously stored in the memory. What do we mean by contiguously stored in the memory? It means that if this is the RAM or the main memory, and these are the memory locations, say if this is array A and this is the first element A0, and so this is the second, and this is the third, and this is the fourth. So this is the first, the second, the third element, the fourth element. Contiguous means that they are stored in series and there is no gap in between. So if this is the first element, the next would be the second element, the next would be the third and fourth. There is no gap in between. Okay, that's the whole array structure for array A. So that because they are contiguously stored in the memory, one advantage is that the elements are easily accessed or traversed from first to last. Like for example, this C code, say we declare A as an array of 10 elements of type integer, and we can easily access each element by using a for loop. We could just use a loop variable I that is set initially to 0, and while I is less than the size, so I would be from 0, the first iteration, up to 9, because that is less than. The size, which is 10, is not included as a value of the loop variable I. So it's only from 0 to 9. And so inside, for each iteration of the loop, we could access the element AI. Again, one advantage is that elements are easily accessed because we know that they are contiguously stored in the memory. Okay, so when you access this, you just increment the index, you could access the next, increment the index, you could access the next, and so on until you reach the last. The second advantage is that you could easily insert or add a new element at the tail or the last of the array. Say for example, currently there are 4 elements and you want to insert the 5th element at the end or at the tail, then you could just simply say after that, you could just increment I and set the whatever is the new element, right? So you could easily add here without moving any of the existing elements. And the third is you could easily delete the last element. You could easily insert at the end of the array and you could easily delete this one without moving all the other elements. For the disadvantage of array structure, first we have this. Inserting a new element at the middle position or worst at the first position, since succeeding elements must first be moved one position downwards, starting from the last up to position +1 to make room for the new element. Say we have this array A, int A, say the size is 10, and this is the first element, second, third, and fourth. Say we have here 5, 7, 1, 3. And we're going to insert a new element at the middle position, or the worst is at the first position. Say for example, we are going to insert at position 3. We're going to insert a new element, say 2, at index 2. In order to do that, to insert 2 here, you need to move 3 down. So you have to move that. And you move this one here. So that is replaced by 1. After you have moved 1 and 3 and then 1, then this space now is free and you can assign there in that memory location the value 2. So that is actually what happened inside the computer system, the memory. Now, every time you move an element down to make room for the new element, that is one statement executed. Okay, so you would say A I plus 1 gets A I, right? So this is the previous element. It is assigned to the next position or the next location, the I plus 1 index. So the one at the ith index will be assigned to the I plus 1. And you have to move the last first to the next vacant and then the second to the last to the next position so that this will be a free space for the new element to be inserted. Now, why is that the worst position is at the first location or position? Because there will be many elements to be moved. Say, for example, this is the original array would contain 5, 7, 1, and 3. Okay, this is your A0, A1, A2, and A3. If you're going to insert at that location the new value 2, you want to insert 2 at index 0, then what will happen is that at this position A4, you have to move this one there. That's one statement being executed. So moving 3 here. And then next statement to be executed is you move 1 there. So this would now become 1. And then next you move 7 here. So this would now become 7. And then lastly, you move 5 to this position. So this becomes 5. And after that, this memory location would be free for the new element 2 to be inserted. So that's the time we insert 2. So this statement is executed how many times? It's 4 times, right? This is executed 4 times. So your I is from 3 down to 0. So this is 3 moved to 4. And then next iteration, okay, so say that is a for loop. Next iteration, this would now be 2. So your I is decremented. From 3, it becomes 2. So this would now be 2 is moved to 3. And then decrement, this becomes 1. 1 is moved to index 2. And finally, the last in decrement I, it becomes 0. So A0 will be moved to A1. So this is executed 4 times. And the more statements you execute, the more tasks you do, the longer the running time. And that is not good, as we have studied in the previous lesson that algorithm with longer running time is not good. So if you could do it in shorter time, then the better. When you insert at the middle position, or worst at the first position of the array structure, many elements are needed to be moved so that you can make room for the new element to be inserted. The second disadvantage is deleting an existing element at the middle position, or worst, again, at the first position, since succeeding elements must first be moved one position upwards, starting from position +1 up to the last to close the gap. So say we are going to delete the second position, element 7, then what we're going to do is to move up all the succeeding elements of the one we're going to delete. We're going to move it up, move one position upwards, starting from position +1. This where position is that position where you're going to delete from. So +1 of that is 1. You move it up, so this becomes 1. And then next you move this up, this becomes 3. So the result now is 5, 1, 3. This is your A0, A1, A2. And then you decrement the size. So in effect, you are executing this statement. A I plus 1 is assigned to AI for I from position 1 up to size minus 1. So position plus 1 is this. You move it up, okay? So the higher index goes to the previous index. So moving up. And you have to do that from this up to the last, okay? So size minus 1, or where size is the number of elements. And the worst position to delete from is at the first, because you are moving a lot of elements. So if you're going to delete, say for example, you delete 5, you're going to move 7 up, this becomes 7. You're going to move 1 up, this becomes 1. And then you move 3 up, this becomes 3. So the result is 7, 1, and 3. Okay, so that is your new array structure with only 3 elements because you delete the first. So when you delete the first, how many elements are moved? It will be size minus 1. Originally, the size is 4. So size is 4. 4 minus 1, you are moving 3 elements. When you delete 7, like in the previous example, this is 5713, where this is your A0, A1, A2, and this is your A3. If you delete this one, you move only 2 elements, right? If you delete 1, how many elements are you going to move? It's only 1, right? So this becomes 3. If you delete the first position, you're going to move size minus 1 elements. If you delete the second element, you're going to move size minus 2 elements. So 4 minus 2, so only 2. You're going to move only 2 elements. If you're going to delete 1 position, this position of 1, you're going to move only 1, and that is 3. So the worst is at the first position, and that is the time when you are going to move the maximum number of elements, and that is size minus 1. Now what if you have 20 elements? Say this is your A0, A1, this is say equal to 1, 2, 3, 4, 5, 6 up to 20. This is your A19. If you're going to delete this one, you're going to move 2 up, move 3 up, move this one. All are moved, okay? Size minus 1 elements are moved up, where size is 20 minus 1. So you move up 19 elements, and that's a longer running time. If you delete this one, 19, then only one element is moved up, right? You don't move all the rest. Again, deleting an existing element at the middle position, or the worst is at the first position. The easiest way to delete where you don't need to move any existing element is at the tail, right? So when you delete that, you just decrement the size so that from 20 elements, that becomes 19 elements. So this is your first reference. This is your starting point, 19. So that would cover only this one. 20 is no longer considered as part of the array structure. And you don't move any of the elements when you delete or when you insert at the tail or the end of the array structure.